Alright, today what we're looking at is just extending further what we have been looking at. So equilibrium, just basically equilibrium, something's in equilibrium, the forces are in balance. So all the forces add up to give you zero. So in this particular bit we're going to be using some trigonometry to help us out. Alright, so let's have a look at some examples. Alright, so there's our example. A mass of 10 kilos is suspended from a string. The string is pulled horizontally by a force of 150 Newton. Find the angle of force matrix with the string. So we've got to figure out what that looks like. So mass of 10 kilos is suspended from a string. Okay, so it's got to be attached to something. We've got a string here, we've got the mass of 10 kgs. So that's what that would be looking like. We then get a force and we pull it that way. So we're going to think about what's going to actually happen when we apply that force and pull it that way. Well, what's going to actually happen is this thing's going to move that way. Alright, and eventually what's going to happen, so our mass is going to be off a bit of an angle like so. We've pulled it to the side there with 150 Newton. There's going to be some tension in that string, and of course the other thing that I haven't drawn yet is the weight force. Alright, so if that thing then is in balance, we then just need to resolve our forces. Now, we've got two dimensions here. The easiest thing for us to do is to separate it up. And so you can either use the I and J components thing, or you can just go, say, vertically and horizontally. Alright, and work at that. Now, if we're going to work with that, we need to do something. So if I put a dot in there, and that here is at the angle, and I'm going to call it alpha. Alright, so vertically, what do we have? Alright, we have, if I split my tension force into two components, a horizontal and a vertical component, then vertically that's this part there, so that's tension sine of alpha, whatever that is, but that's got to equal the weight force. So tension sine of alpha has got to equal 10 times 9.8, so tension sine of alpha has got to equal 98. Alright, so there's one thing that we've got. So that's the vertical. Horizontally, what have we got? Well, horizontally we've got two things. We've got that one there, and we've got this one here. So the first part, the force tension we've got is the tension cos of alpha. It's got to equal 150 degrees. And then 150 degrees to 150, I should be saying. So what have we got then? We've got two equations. T sine alpha equals 98 and T cos alpha. So if I take those and I just say that T sine alpha over T cos alpha has got to equal 98 over 150, the t's cancel. Sine alpha on cos alpha is tan alpha, which is 98 on 150. So if I want to find out what that angle is, I'll do the inverse tan of 98 on 150. And when you do that, you get 33.16 degrees. Alright, so let's go back to what we're looking at. Back to the question, just to check. It says find the angle the force makes with the string. So the angle that the force makes with the string is actually that angle in there. Call it theta. What we found was this one. So of course they're in a straight line, so 180 minus that. So the angle of the string is theta, and that's 180 minus that 33.16, which is 146.84 degrees. Alright, so there's the first example. Okay, so here's our example that we're looking at. So a mass of 5 kilograms suspended from a beam by 2 strings as shown in the diagram. Find the tension in each string. Okay, so we're going to come up with a whole series of equations here. And then from those equations, we then solve them. Alright, so we're going to work out, again, horizontal and vertical components. So horizontal components, we've got to break this tension up. There's the horizontal component there. This here is the horizontal component. Vertical component. Vertical component. Alright. So, from there, what else have we got? Well, there's some angles. That angle, let's call it alpha. That angle, let's call it beta. We don't know exactly what they are. So now basically we've just got to come up with some equations. So that one there, that force there would be T1 cos alpha. This force here would be T2 cos of beta. That force there would be T1 sine of alpha, and that force there would be T2 sine of beta. Alright. And the other thing, of course, is mass. So that there has a weight of 5 times 9.8 equals 49 Newton. So we now resolve horizontally and vertically. But our alpha and our betas, we really need to know them, and we do have information that tells us that. So if you have a look here on our diagram, there's 10 centimetres there and a 5 centimetres there. So what that tells me is these two strings, that's 10. That's a right angle, and that's 5. So this angle in here, if that's alpha, then alternating angles tells me that that's alpha as well. So from that, I can get sine alpha is opposite over hypotenuse, 5 over 10. And then from that, alpha will be sine minus 1 of a half which is 30 degrees. Now if that was our alpha, and this angle there is beta, so that makes that beta, and so beta is equal to 90 minus 30, because it's a right angle triangle. 90 minus 30 is 60 degrees. Alright, so now we can look at our horizontal and our vertical stuff. So horizontally, we've got these two red ones. So horizontal, T cos beta, so T cos theta, T2 cos 60 equals T1 cos alpha. Alright, T2 cos 60 equals T1 cos alpha. T2 cos 60 equals T1 cos alpha, and alpha was 30, wasn't it? Alright, so root 3 on 2 T2 equals a half T1. So root 3 T2 is equal to T1. Alright, so we'll save that. Alright, vertically. So let's go and have a look at what we've got vertical. Well, vertically we've got this weight force down, and we've got these two forces acting up. Alright, so T1 sine alpha plus T2 sine beta is equal to 49. So sine 30 plus T2 sine 60 is equal to 49. So that's a half T1 it's not what I'm talking about. Sine of 30 is it is a half. I'm not talking about. So alright, Dan, I've just realised I made a mistake, and hopefully you've picked that up here. Cos 30 is not a half, and that's not that. Cos 30 is root 3 on 2, and cos 60 is a half. So what that means is that T2 is root 3 T1. Well, I picked that up. Hopefully you picked that up earlier. Sorry for the confusion. So, sine of 30 then. Sine of 30 is a half, so it's a half T1 equals, not equals, plus root 3 on 2 T2 equals 49. Now, T2 is that, so we get half T1 plus root 3 on 2 times root 3 T1 equals 49. So what then we've got is a half T1 plus root 3 times root 3 is 3, so 3 over 2 T1 equals 49. So you've got 4 over 2, so 4 over 2 is 2, 2T1 equals 49. So the tension in string 1 is 49 divided by 2. Alright, which is 24.5 Newton. Alright, so if we know that then, and we also know the relationship here that T2 is root 3 T1, so to T2 is root 3 T1, so that's square root 3 times 24.5, which when we work that out becomes 42.44 Newton. Alright, that's it to there. So sorry about that muck up with those values there. So you just need to basically think about these, and as we've gone through here, there's horizontal and vertical components. Alright, and so you need to look at those. There may be some other information, or you may be given angles, but yeah, you need to think. So horizontal, vertical components is the way we go. Alright, so that's exercise 14C, set 8.